In this video, I'm going to cover the differences between Java and C#. To be honest, there aren't many differences, but I'll go over the differences that we do have. Just to be clear, I'm not going to cover all the differences, just the big major differences, but there will definitely be some other little things you might come across that you'll need to look up when you start writing Java code. One thing you will notice in a moment is that Java takes a lot more work than C# to get set up. You see, Java is an interpreted language. Well, sort of. When you compile Java code, it gets compiled to Java bytecode, and this bytecode is then executed inside something called the JVM. The JVM is the Java virtual machine, and your Java bytecode is executed within this JVM. This of course makes sense since the whole idea is Java can run on any platform as long as there's a version of the JVM for that platform. In many ways this is similar to C#. C# compiles to a language called IL, which is then embedded in the exe file, and provided the machine has the .NET Framework or Mono installed, then compiled to the native machine's code live as the program runs. So they're pretty similar. And this means that anytime you want to run a program that needs Java, like Minecraft, you need to install Java. You need to have that JVM to be able to run this bytecode. So in that case, you download Java from the official Java website, which they only just modernized. And when you want to run Java programs, what you'll end up downloading from the website is something called the JRE, the Java Runtime environment, and this provides the JVM and various other things Java needs to run. It doesn't come with any developer tools, like a compiler, however. To get those, we need something called a JDK. This is the Java Development Kit. This has the compiler and other development tools we need to make programs using Java. One thing that is important to note is the JDK comes with everything the JRE has. So the JDK is essentially just the JRE with some extra stuff thrown in there for development like a compiler. That's it. This means that if you don't have the JRE installed on your machine, you don't need to install it. The JDK comes with all of the JRE things too, like the JVM, so we won't have any problems running our program after we've compiled it. Okay, now there's something important to be aware of that's just recently come up with the JDK. Oracle has introduced a new licensing system, which means if you use the JDK for developing commercial programs, you have to buy a license. So sure, for personal use it's fine, but if you want to use Java for an application that will get you even the slightest bit of money, you either have to pay for a license or use something called the OpenJDK. OpenJDK is an open source Java development kit based on the original JDK, and not only is completely free, so you won't need a license, but Oracle themselves have made it quite clear that they absolutely support what OpenJDK is, which of course begs the question of what's the point in paying for the official Oracle JDK when you could just use OpenJDK for everything, including commercial use. And the biggest reasons are that with the official paid JDK, you get support from Oracle if something goes wrong, you have access to loads more tools than you get in OpenJDK, and biggest of all updates are straight from Oracle, while they'll be from the open source community in OpenJDK and a bit slower. So that's something to keep in mind. Let's first go over how to install the JDK, then we'll start looking at how Java differs from C#. We'll nice and quickly cover this for Windows, macOS and Linux. They're all very similar. Let's try and get through these quite quickly so we can cover the language. And these apply to both OpenJDK and Oracle JDK. There will be some differences, but they are mostly the same. I'll show the Oracle JDK, but they're both configured in the same way. On Windows, you can just get the installer and run it, no problems there. But there is more configuration we have to do once this is done, just in case it hasn't already been done from the installer. On macOS, it's essentially the same. We'll download the installer and run it. But there's more to this, and we'll get to that in a moment. If you're on Linux, there are a range of choices, and on Debian-based systems and systems that support installation from RPM files, you could most likely just use the packages provided. But I won't cover that, and from what I tried, they didn't exactly seem to just work. So what would be easier, since we know what's going on ourselves, and in my opinion the best way, because this just straight up works across all distributions of Linux, is to download the binaries from the Oracle website in the tar.gz format. Then extract out that archive and you'll get a folder from the archive. Now, all we need to do is move this folder we just extracted over to usr-lib. We'll need to do this as root, of course. Now, this alone isn't enough because they aren't in the path, but we need to be able to run Java to run our programs and Java-C to compile our programs. So we'll just very simply create a symlink to those files, which is just the equivalent to a shortcut, in the usr bin directory, where they are accessible through the path. To do that, we'll use ln-s followed by the source and destination. The source, so where the Java and Java-C executable files are, is inside the folder we just moved over, and within the bin directory within that. So you'll end up with something like this. The version numbers will probably be different though. Let's do Java first. Then we just follow that by where we want to create the shortcut, which is in usr bin, and we'll call it Java. Then we'll do exactly the same, but instead of Java, we'll do Java-C, so we can compile Java code, and later on you might find yourself using other executables like Java-WS, so you create links for those as you need them. And now, you should be able to write Java-version and Java-C-version without any errors, which means it works. Alright, but now across all platforms, there are some other things we need to do. We need to make sure the path is correct, and another environment variable called Java Home are configured. On Windows, you can either access this by just searching environment variables, or searching this PC and hitting Properties and Advanced System Settings. Now, we just choose environment variables down here, and we'll see all the environment variables. If we take a look at the path, it should have something related to the JDK in it. However, if it doesn't, like here, we need to add that. So, we'll add to the path where Java is. We'll find Java inside program files and just Java. Then we choose the JDK version we just installed, and the bin directory within that is what we'll set it to. On top of that, if there isn't a Java home variable, we also need to set that. And we set it to the folder that the bin folder is in, not the bin folder itself. So it's slightly different from the path, it's one folder up. Now, in order for this to work, you need to restart your computer after doing this, and that is so important. On macOS, we don't need to worry about the path since the installer handled all that for us. However, Java Home isn't configured. So within the bash profile folder in our home directory, we'll need to set it. And we can do that by writing export followed by Java Home and setting it to the usr libexec Java Home. This will only apply to this user though. Similarly, on Linux, we need to fill in the Java Home. Path is already sorted since we created the link in usr bin, but we still need to set Java Home. If we want to do that for all users on the system, we'll modify etc profile to set Java Home to the directory our JDK was stored in. So, we'll write export followed by Java Home, an equal sign, and the folder we copied. That was in usr-lib. Since I'm in Vim, I can check what the folder name was so I can set it correctly. Great, now everything is properly configured, regardless of your platform. Alright, let's dig down on the code. I'm going to be using the IDE IntelliJ IDEA, which is very similar to Visual Studio in many ways, and will take essentially no effort to get going, provided you set Java Home and everything else correctly. However, you absolutely don't have to use it. You can use Java in the command line to execute your Java programs, and Java-C to compile your programs. There's lots of documentation and I'm sure you can figure it out. Now, if you are using IntelliJ, we'll just create an empty project. To do that, make sure Java is selected in the new project window, choose an SDK version, don't worry about any of these, make sure they aren't ticked, and hit next. Then, tick this, and choose command line app, otherwise things aren't going to work. And then we'll give our project a name. Now, notice how it's asking us for a base package. So, that's our first thing. What are packages? Well, packages are essentially namespaces. So if I have a package called A, within that package, we can put classes in there. So it's exactly the same as the folder structure you can get in your C# projects. Then if I want to access that class from outside that package, we need to import that class. Now, this is different from C#. In C#, you say using followed by whole namespaces, and that makes everything inside that namespace accessible. In Java, you use something called import, and you have to import individual classes. So if I wanted to access this hello, I would say import a.hello. However, you can also use wildcards, so you can say import a.star, which will import everything within the package A. You'll find that IntelliJ lets you just import classes as you need them, by putting your mouse over any errors, so you generally won't need to worry about this yourself. You'll also notice that if I make a package and make a package within that, it will join up into one a.b for neatness. Now, one important thing to point out is that these packages are only in the source files. Essentially, all of your project's code is contained within an src folder, and that's where you have your packages. It's only the actual code that's put into packages. Everything else, like resources, are stored in just normal folders. But wait, how are these packages different from just folders then? Well, technically they aren't. These packages are stored as folders in our file system. They're just called packages. It's just a clearer way of representing them. But really, they're just fancy names for folders that behave exactly like C# namespaces that you use to organize your code. So, the base package is the whole package that our entire project is going to be put in. So now, we need to look at naming this base package. The first thing you need to keep in mind when naming packages is that they need to be lowercase. Do not put uppercase characters in the package, and you can only put letters and underscores in package names. Nothing else. So that's important to keep in mind too. Now, there's a general naming convention when naming your base package, the package that your whole project will go into. You're supposed to name it based on your website. So for me, my website is abworld.ml. So you do that in reverse, meaning my base package name would be ml.abworld. But what if you don't have a website? Well, then things get a bit tricky. Java doesn't really say what you should set it to in that case, but just make sure to set it to something that's unlikely to conflict with something else, since that's the whole point of it. Maybe I would call it com.abworld or com.abmedia or something like that if I didn't have a website. Up to you. So, once we've set that package name, we can just go ahead and create the project. Now we can use system.out.println, giving it a string to print some text to the console. Then, when we execute it, we'll find our text displayed in the run section down here. Let's start off by focusing on the types. Now, in C#, every single class or data type inherits from one big base object called object. This means that every single object has equals, getType, getHashcode, and toString on them. And that's everything, from strings to integers to just everything. However, Java has a similar system where it also has an object type, but not everything inherits from it. Some primitive types, like integers, don't. But for the most part, more complex data types do, so that's something to keep in mind. In Java, anything that isn't a primitive will have a capital letter at the start. For example, a string isn't considered a primitive, therefore it has a capital S, and it does inherit from object. Alright, another thing that's different with the type system is enumeration. In C#, enums are literally just integers. There's nothing more to them. They're just fancy integers, just syntactical sugar if you like. If I make an enum in C# and put 4 values in there, each of these values will automatically be set to 0, 1, 2, 3, and so on. But we can manually set each of these to a different number. These pretty much just get substituted for numbers. There's nothing too special about them. In Java, however, it's a whole different story. Enums are essentially classes and arrays joined together. Now, fundamentally, it looks almost the same, and you can use it almost the same way too. Let's hop into the code and take a look. Let's make an enum called device. And within here we'll have a phone, a tablet, a laptop, and a desktop. Now yes, in Java you often put the things within enums as all capitals, so keep that in mind. So far, this is the same as C#, and we can use these the same way. But we need to know what's going on here to take this to the next level. You see, this enum is actually just a class, and each of these are instances of this class. So this is where things get clever, and this can be quite useful too. I can put some fields in this enum. Now, watch this. If I make a variable of type device and set it to device.phone, there's now a screen width and screen height within this. If I write device.tablet, it has a screen width and screen height on it. What's happening is this enum is a class, and these are just constant instances of this class. I could do exactly this with a plain class. I would create the class, give it these 2 fields, then create each of these as static constant instances of this class. And you get the idea. But of course, this would take more effort, and enum just gives us this in a much easier to use format. Alright, fine, but let's take this up to the next level. What we can now do to take this even further is to create a constructor on this enum that takes in the width and height and sets them properly. Now we can just provide the parameters of the constructor for each of these. So these are just random numbers I'm making up, but let's just say that the phone screen is 600 pixels wide and 1200 pixels high. We'll do some brackets because we're providing the arguments for this constructor, followed by the width and height. And you'll notice here that IntelliJ is showing us what parameters we're providing the values for. This is just something IntelliJ does. It's quite convenient when I think about it. It would be nice if Visual Studio had this, because it tells you exactly which argument is going to which parameter. So let's just set some random sizes for every single one of these. Each of these have a different width and different height. We could add even more sub-properties to these. I think you can see how this is quite powerful in comparison to C# enums. We can also put methods in here too, and pretty much anything else you can get in a class. Right then, the next topic to talk about is properties. This is something you'll definitely notice. In Java, properties don't exist at all. Instead, you use something called accessor and mutator methods in Java. This isn't really a feature of Java, but it's a pattern that almost all Java developers use. Let's create a class and call it C for class. Then, within this class, we'll have a string variable in here, but we'll keep it private. Then, we create a getting method and setting method. And these will do what you would expect. This is the accessor method here, and this is the mutator method here. If we want to have a variable that we can only get, we just don't provide the setter. And this is an extremely common pattern in Java. This is everywhere. Let's take a look at exceptions next. Now, this is something that is quite different between Java and C#. In Java, you have two different types of things that can go wrong. You have something called an error and something called an exception. Now, an error is a major error that comes from something internal in the language, like the JVM or something like that. Chances are you will never need to handle errors or even look at them. However, exceptions are different. Now, if I take a look at what's going on inside exception, we have a range of exceptions, but also something called a runtime exception. And there's a pretty big difference between the two. Anything here that just inherits from exception is something called a checked exception. And anything that inherits from runtime exception is something called an unchecked exception. But what does this mean? Well, a checked exception is an exception that you must handle. You have to handle that exception at some point down the line. While an unchecked exception is an exception that you don't have to handle. And unchecked exceptions usually come internally from Java. So things like dividing by 0 or trying to access an invalid method in a class or something along those lines. When you make methods, you should always make checked exceptions, never unchecked exceptions. In C#, all exceptions are unchecked. You don't have to handle them. They'll just crash the application if they occur and they aren't catched. So, how does the check system work in Java? Well, let's think about a very simple application. We have three methods like this, and this is the call stack. So, within a method called method 1, that we called from method 2, which was called from method 3. Then, inside method 1, we throw a checked exception. What happens is, we get a compiler error inside method 1, saying that the exception is unhandled. So it's telling us that we need to deal with this exception, and we need to handle this exception inside method 1. So we could deal with the exception inside method 1. We could put a try catch in the same method the exception is thrown. And now we don't get a compiler error anymore because we've handled the exception. That's how you handle exceptions, you just catch them in a try catch. But what if it needs to be handled somewhere higher up? Of course, sometimes you can't handle all these errors at the same level you throw them, in a way that kind of defeats the point. Sometimes they need to be sorted out at a higher level. For example, if we have a method that makes a connection to a server, and then we have another method that prepares the address. If we failed the address and threw an exception in here, we don't want to handle that exception in here. We want to sort that out in the place we're trying to make the connection to the server, because that's the level where we're able to say to whoever wanted to make the connection that the address was invalid. That's where we want to handle it. We don't want to deal with it in the smaller part that processes the address. So back to our three methods. In order to tell Java that this exception needs to get handled from the person that calls method 1, instead of method 1 itself, we add to the method's declaration the word throws, followed by the exact type of exception this throws. So this tells Java that this method can throw that exception unhandled, and now the responsibility is pushed up to method 2. Now it's up to method 2, because that's the one calling it, to handle the exception. We could also do the same to method 2 if we wanted. We could add to method 2's declaration that it throws a given type of exception, which once again tells Java that this method, method 2, can throw that exception unhandled. And now yet again, the responsibility has been moved up to method 3. Now it's up to method 3 to catch the exception. And we can add multiple exceptions to this throws thing here. We can specifically handle some exceptions, but leave other exceptions to be handled higher up. Now, there is a lot of controversy surrounding checked exceptions. Some people think they're good, some people think they're bad, because on the one hand, they make sure your code always handles exceptions at some point. Your application is way less likely to crash. But on the other hand, this throws bit here can get exponentially bigger, as you can see in this image here. The amount of exceptions this method can throw that need to be handled can just get bigger and bigger. And on top of that, some people also don't like it because some developers will just leave empty catch blocks to stop it from having to be handled properly. But that's really bad, please don't do that. Now then, what about unchecked exceptions? If we have this great check system, why are some exceptions unchecked? There's a class called the Runtime exception class, and if you make an exception based on that, it's unchecked and doesn't need all that. Well, remember that earlier, I said that internal exceptions are unchecked. Like, for example, dividing by 0. That's an unchecked exception. That's because Java decided that it would be near madness to try and work out every single little exception that could come from things like that. Imagine if every single time you divided by a number, you had to say that this method can potentially throw a divide by 0 exception. Things would get very messy very quickly. And that's why the absolute fundamental things like division or accessing members on an object are unchecked exceptions. Essentially, the official way Java looks at it, although as I've said, people do have different opinions about this, is never make unchecked exceptions in anything you do. It's only the absolute fundamental things that should give off unchecked exceptions. Right, hopefully that makes sense. It's really difficult to explain that, but try it out in your own code and you'll get an idea of how it works. Next thing to talk about is inheritance. One of the most important parts of object-oriented programming. The biggest difference is how you make a class inherit from something. If you're inheriting from an interface, you write implements followed by the interface or interfaces. And if you're inheriting from another class, you write extends followed by the class. In addition to that, in C#, you need an override keyword when you're replacing a method in a subclass. However, in Java, you don't need to override. If I make class A and class B, and put a method within class A, then make class B inherit from class A, I just put in the method with the same name as the one in class A, and it will replace the one in class A. Most other things are the same. However, one thing you will notice is that virtual isn't a thing in Java. All Java methods are virtual. You'll notice that I can provide code for the method in class A and class B will just replace that code. I don't have to mark it virtual. I only have to mark it abstract if I provide no code for it, as well as making the class abstract, of course. Alright, I'll just quickly mention some of the other smaller differences you have. You'll notice that I can only have one public class per file, and that public class needs to have the same name as the file it's in. We can make lots of smaller non-public classes, but it's one public class per file, which is of course different in C#. Also, the equivalent of the C# term const is final in Java, and in C# you can use using to make sure an object gets disposed. In Java that's called try. In Java there are no multi-dimensional arrays, thank God. In Java you can create arrays like this, with the square brackets after the variable name, and it's exactly the same as putting the square brackets after the type. And finally, in Java there's a keyword called strict FP that you can add to classes or methods that make sure floating point numbers are handled the same across all different systems. Alright, well, I hope this video was helpful. I dove into some of the biggest differences between C# and Java. The biggest difference being the installation. If you want to see more videos, mainly related to C# or C++, or really just any programming topic, feel free to subscribe and feel free to suggest any videos in the comments. This video came from a suggestion, in fact. Alright, bye.